Friends, in this video we are going to discuss design of IR filters in terms of diaphragm 1 and diaphragm 2 realizations. See, draw the block diagram of DF1 means diaphragm 1, DF2 means diaphragm 2 realization for a digital IR filter described by the system function h of z equal to 8 into z to the power 3 minus 4 z square plus 11z minus 2 divided by z minus 1 by 4 multiplied by z square minus z plus 1 by 2. This is the system function, nothing but a system is given. A system is having input sequence x of n and output is y of n, and its impulse response is h of n. This is the given system is represented in terms of system function, that is given h of z here. Now we have to realize this system function in terms of diaphragm 1 and diaphragm 2 realization. So in order to represent in terms of df1 and df2, we must know the system function should be represented in negative powers of z, because we have basic elementary blocks, those are delay elementary blocks z raised to minus 1. Because of that reason, we are going to represent, or we are going to express given system function in terms of negative powers of z. So for that, the given system function I am going to simplify first. Let us simplify the denominator. After simplifying, I got like this, 8 into z to the power 3 minus 4z square plus 11z minus 2 divided by z cube minus 5 by 4 z square plus 3 by 4 z minus 1 by 8. As I told, we have to express in terms of negative powers of z. So for that, observe the numerator and denominator term. Highest power of z we have to observe here. Highest power of z is 3 is there. So let us multiply the numerator and denominator term by z to the power minus 3. Once again I am repeating, multiply the numerator and denominator by z to the power minus 3. Then we are getting h of z equal to 8 minus 4 z to the power minus 1 plus, here multiply z to the power minus 3 means it becomes 0, hence it is 8. Z to the power 0 means 1. 8 minus 4 into z to the power minus 3 means it becomes minus 1, plus similarly 11 into z to the power minus 2, 2 into z to the power minus 3. Similarly 1 minus 5 by 4 z to the power minus 1 plus 3 by 4 z to the power minus 2 minus 1 by 8 z to the power minus 3. Hence we multiply the numerator and denominator by z to the power minus 3. So then we got this step. Okay, now let us express in terms of df1 and df2. Before realizing in terms of df1 and df2, I am going to split the given system function in terms of 0 system and in terms of pole system. How to express in terms of 0 system and pole system? This is the given system function. Now let us see in terms of diagram. X of n is the input, and I am going to, we know the numerator part indicates 0 system and the denominator part indicates pole system. So I am going to split in terms of two subsystem functions, h1 of z, h1 of z, and second subsystem function h2 of z. Output is same, input and output remains same. So here h of z is the given subsystem function, sorry, given system function. X of n is the input and y of n is the output. X of n is the input and y of n is the output. That system function I splitted in terms of 0 system and pole system. Always we know the system function. In the system function, numerator polynomial will give the 0 system and denominator polynomial will give the pole system. So I express nothing but h of z equal to, from this diagram we can say that h of z equal to h1 of z, cascade connection, h1 of z into h2 of z. Series connection means cascade connection. So I am going to represent this intermediate result as v of n, where v of n is the intermediate result, or we can say v of n is the output of first subsystem function, that is given as a input for the second subsystem function. So it is the intermediate result. We are going to express it as a intermediate result. Hence, first observe only zero system. Zero system means here uh, system function is nothing but it is the ratio of what output by input. So hence h1 of z is what, h1 of z is what, it is the ratio of output. Output means v of n. It is z transform of v of n is v of z by x of z. And what about h2 of z? Now this one we expressed h2 of z. H2 of z equal to what? What is the output here? Y of z divided by v of z. Fine. As I told, h1 of z indicates zero system and h2 of z indicates four system. In the given system function, if h1 of z is representing zero system, numerator term is zero system, hence h1 of z equal to 8 minus 4 into z to the power minus 1 plus 11 z to the power minus 2 minus 2 into z to the power minus 3 that is equal to what? V of z by x of z. Correct? Zero system. Now cross multiply. Cross multiply means v of z equal to what we are getting? V of z is equal to, we are getting 8 into x of z minus 4 as it is z to the power minus 1 x of z plus 11 z to the power minus 2 into x of z minus 2 z to the power minus 3 into x of z. So what I did, I have taken this x of z towards this side. Let us take inverse z transform. Let us take inverse z transform. So it becomes v of n equal to 8 into x of n minus 4 as it is z raised to z to the power minus 1 into x of z, nothing but x of n is divided by one time, that is x of n minus 1 plus 11 x of n is divided by twice x of n minus 2 x of n is divided by thrice, that is minus 2 as it is coefficient term x of n minus 3. Hence we got equation in terms of time domain. Now let us represent this expression, nothing but this is representing first subsystem function. We expressed first subsystem function, that is zero system, uh, in terms of what? V of n indicates what? Output. In x of n indicates what? Input. So this one we are going to represent in terms of elementary blocks. See, very simple. Here in this case, now we are realizing this one. In this case, x of n is input and v of n is output. So x of n is input and v of n is output. Let us go step by step. First one, 8 into x of n. So x of n is multiplied by 8. So the multiplication is indicated by arrow mark. So in this stage, what we are getting? 8 is multiplied to x of n. In this stage, after this, we are getting 8 into x of n. Next, coming to this part, x of n is divided by one time. X of n is delayed by one time. So let us make use of one delay element z to the power minus 1. So it will give what? X of n is delayed by once. So in this stage, what we are getting? X of n is delayed by one time, hence it is x of n minus 1. That is multiplied by the coefficient of minus 4. That is multiplied by the coefficient of minus 4. So what happens here? First, what we got? X of n is multiplied by 8, and it's in this case, what we got? 8 into x of n. Next term, x of n is divided by one time, that is x of n minus 1. Coefficient term is minus 4, and these two are what? Added. These two are what? Added. These two are what? Added. Coming to third term, see here, x of n minus 2. X of n minus 2 means x of n is delayed by twice. Already in this stage, we got one time delay. One more delay element you can make use, that is z to the power minus 1. So in this stage, what we got? X of n minus 2. X of n minus 2. That is multiplied by what? Coefficient term. Coefficient term is 11. That is, this operation is, after performing this operation, it is added to the previous result. So I am going to add to the previous result. Next, last term, x of n is divided by thrice. One more delay element, and that is multiplied by minus 2. Coefficient term is minus 2. This entire, after performing this operation, that is added to the previous result. So add to the previous result. So we realize in terms of what? Elementary blocks. This indicates direct df1 realization of what? Realization of zero system. Only one first subsystem we realize, zero system. Only this part we are realized. Next, coming to this part. So H2 object indicates what? H2 object indicates pole system. Pole system means in the given system function, the denominator polynomial indicates pole system. Next is pole system, realization of pole system. See here, pole system means this part. uh, H2 object equal to what? It is the ratio of what? Y of z, y of z divided by output by input, y of z by v of z. But H2 object equal to, it indicates the pole system means it indicates the denominator polynomial. Denominator polynomial means 1 divided by this much. That one I am going to write here. Hence H2 object equal to y of z by v of z, that is equal to 1 divided by this much. Let us do the cross multiplication. This term will go, to the left side, and this term will go to the this side, and that is y of z into 1, y of z into minus pi by 4 into z to the power minus 1, that is minus pi by 4 z to the power minus 1 into y of z. Next, 3 by 4 z to the power minus 2 into y of z. Next, minus 1 by 8 z to the power minus 3 into y of z. This will go where? This side, that is equal to v of z. Let us take the inverse z transform and rearrange the terms. This entire part will go to the other side, because we are going to express in terms of output is what? Y of n. Express y of n, nothing but output in terms of input. So let us take the inverse z transform. Inverse z transform of y of z is y of n, and inverse z transform of v of z is what? V of n. And if this term will go other side, and this side minus becomes plus, so plus 5 by 4 as it is. Inverse z transform this one is y of n minus 1. This, if this goes other side, means it becomes minus 3 by 4 y of n minus 2. It becomes plus 1 by 8 y of n minus c. Let us express in terms of elementary blocks. What is output? Y of n is output, v of n is output. Let us see one by one. First, v of n is, what is the coefficient term? 1 is there. Coefficient term is 1 is there, multiplication by 1. So v of n is multiplied by 1. Next, go for second term. Y of n is divided by 1 time. So y of term is here is there. So I am going to delay this by 1 time. So what we are getting? In this stage we are getting y of n minus 1. Y of n minus 1 is multiplied by the coefficient term, that is 5 by 4. 5 by 4. This operation is add to where? This operation is add to v of n. So I am going to add here, plus this operation is added to here. Next, go for third term. Y of n is divided by 1 time, twice. 1 time delay is there, and perform one more time delay, that is z to the power minus 1. So in this stage what we are getting? Y of n minus 2. Coefficient term is what? Minus 3 by 4. After performing this operation is added to the previous operation. So this is added to a previous operation. Okay. Next, go for third term. Y of n is divided by thrice. Twice delay is there, and perform one more time delay. That will give what? This is y of n minus 3. The coefficient term is what? 1 by 8, and this operation is added to the previous operation. So add to the previous operation. This is what? It is the poles system. Now In the previous case, what we discussed, it is the realization of what? It is the realization of zero system, and it is the realization of what? Pole system. See in the diagram, zero system followed by pole system are in the series connection. Zero system is realized like this, and pole system is this pole system is realized like this. These two diagrams, these two are in cascade connection. These two are in cascade connection. Observe here, in the zero system, output is what? V of n. That is given as the input for the pole system. V of n is the input, and these two have to perform in cascade connection. What happens? See, nothing doing, same. Both we have to connect each other. Output is y of n, and intermediate result V of n is there. Okay, intermediate result V of n is there. First I am going to sketch as it is. Z to the power minus 1, and this one will give x of n minus 1, coefficient term minus 4, and add with the previous result. Next, one more time delay, z to the power minus 1, coefficient term is x of n minus 2, coefficient term is what? 11, add to the previous operation, and one more time delay, z to the power minus 1. Here we are getting x of n minus 3, and coefficient term is minus 2, add to the previous operation. Okay, this is what? Zeros system. This is what? Zero system. See, same thing I did here, nothing changed. Whatever we discussed in the earlier case, same thing I sketched here, same part once again I sketched here. Next, coming to the pole system, y of n is divided by one time, y of n minus 1, coefficient term is 5 by 4, add with the previous operation. Next, one more time delay, y of n minus 2, coefficient term is minus 3 by 4, add with the previous operation. Next, one more time delay, we are getting y of n minus 3, and coefficient term is 1 by 8, add with the previous operation. It is pole system. This overall diagram will give the direct form 1 realization. This overall diagram will give the direct form 1 realization. Okay, thank you very much. The direct form 2 realization, same system function. If you want to realize in terms of direct form 2, in this case one change we have to make, that is interchange the positions of zeros and poles. This one we have to perform. See, in the earlier case, we expressed given system function as a two subsystem functions. First subsystem function h1 of z indicating zero system, second subsystem function indicating pole system. It is for what? Direct form 1 realization. It is for what? Direct form 1 realization. In case of direct form 2 realization, we are not dealing any notation. Notation becomes same, 1 and 2 notation becomes same, but what we are doing, we are expressing these poles are go to here and these zeros are go to here, nothing but interchanging the positions of poles and zeros. So in the df1, first subsystem function h1 of z indicating zero system, listen carefully, and second subsystem representing pole system, it is for what? df1. For df2, the first subsystem function is going to represent poles, and second subsystem function is going to represent zero system. Means we interchange the positions of poles, and poles will go to first system and zeros will go to second system, second subsystem function. That one nothing but that's the same thing I represented in terms of logs. Here the first subsystem function represented as a pole system, second subsystem is represented as a zero system. And what will be the system function? That is h of z. First I will write as it is 8, sorry, in terms of negative force of z, 8 minus 4z to the power minus 1 plus 11. It is the given system function. If h1 of z is representing pole system, as we know denominator term indicates force, that is 1 divided by 1 minus. So h1 of z indicating pole system means the denominator term indicates pole system, that is equal to 1 divided by this much. And let us do h1 of z is what? It is the output of v of z and ratio of output by input v of z divided by x of z. So let us do the cross multiplication. V of z into 1 v of z minus 5 by 4 z to the power minus 1 into v of z. Next plus 3 by 4 z to the power minus 2 into v of z. Next minus 1 by 8 z to the power minus 3 into v of z. This will go to what? This side, that is equal to x of z. Next this entire term, let us take other side because we are going to express in terms of output. Output is going to express in terms of input. Input is what? Input is x of n. So I have taken this entire term towards other side, and let us take the inverse Z transform. Inverse Z transform of v of z is v of n. Inverse Z transform of this one is x of n, 5 by 4. Inverse Z transform of this one is v of n minus 1, v of n minus 2, v of n minus 3. See, same thing. V of n is the output and x of n is the input. First part, x of n is multiplied by 1, and second term v of n is divided by 1 time, and coefficient term is 5 by 4. This operation is added to the previous term, that is x of n. Next second v of n is divided by twice, so one more time delay. Coefficient term is minus 3 by 4. This operation is added to the previous result, so plus here. Next v of n minus 3 delayed by third time, that is v of n minus 3, and coefficient term is 1 by 8. Coefficient term is 1 by 8, that is added to the previous block. It indicates what? It indicates pole system. See, you can observe in the diagram one relation. Same thing we sketched. Pole system means you can compare, do the comparison of these two things. There is no change. Both are same. Both are same. It is the what? See, in this diagram you can say it is the pole system and it is the zero system. Nothing but in case of diagram two relation, these system becomes interchange. It is a shortcut. In the next video we are going to discuss about that one. Now we will discuss thoroughly. So it is the pole system. Similarly you have to realize zero system. Next is second subsystem function h2 of z. It is a zero system. Output is what? Y of z by v of z. Let us do the cross multiplication and take the inverse z transform. 8 into v of n, 4 into v of n minus 1 plus 11 into v of n minus 2 minus 2 v of n minus 3. Output is what? V of n, sorry, y of n output, and input is v of n. So let us take the first term. V of n is multiplied by 8. Next term v of n is divided by 1 time. Coefficient term is minus 4. Similarly v of n is divided by twice. Coefficient is 11. Thrice delay, and coefficient term is minus 2. This indicates zero system. So in this case h1 of z and h2 of z, then y of n, correct? Then y of n is there. Here this indicates in this diagram 2 relation. In diagram 2 relation, this indicates poles, this indicates zeros. So let us make the what? Series connection or cascade connection. Same thing, same diagrams, same block diagrams I am going to connect each other. So after connecting each other I am getting like this. This indicates what? This part indicates pole system, this part indicates zero system. Nothing I did here, same block diagrams I connected because v of n is the intermediate result. See, observe here in this diagram, v of n, in this case v of n is divided by 1 time here, and coefficient term is 5 by 4. In this case, in the zero system, v of n same thing is divided by 1 time and coefficient is different. And coming to second stage, V of n is delayed by twice. Here we are getting V of n minus 1. Here also we are getting V of n minus 1. Here we are getting V of n minus 2. Here also we are getting V of n minus 2. Here we are getting V of n minus 3. Here also we are getting V of n minus 3. So why we have to perform separately twice? Because same term V of n is intermediate result is going to perform same delay here. So because of that reason, in order to avoid double operations, same thing we are getting, same result we are getting, why should we perform same operation separately twice? Because of that reason, what I am doing here, I am taking this delay element common here. Coefficient terms are different for pole system and zero system. Coefficient terms are different, but delay operation is what? One time delay, twice delay, thrice delay. Because of that reason, stage wise I am going to take the common. Same here, y of n, sorry, v of n, I am going to do make the delay elements common here. So this z raised to minus 1, what we are getting here, we are getting v of n minus 1. V of n minus 1. V of n minus 1 is in the pole system. Coefficient term is what? 5 by 4. In the zero system, coefficient term is what? Minus 4. Same thing. After one time delay, coefficient term 5 by 4. Here minus 4. Similarly, second time delay, coefficient term minus 3 by 4 for the poles, 11 for the zeros. Second time delay, that is V of n minus 2. Coefficient term is minus 3 by 4 and 11. Same thing. Simply thrice delay, V of n minus 3, V of n minus 3, coefficient terms are 1 by 8 and coefficient term for the zero system is minus 2. Hence, this is the what? This is the direct form 2 realization. Comparing with direct form 1 realization, direct form 2 realization is very efficient because we are going to take the delay elements common here. The number of delay elements used in the direct form 2 relations are very less. Computation becomes very easy. Because of that reason, comparing with df1, df2 is very efficient, because reason is the number of delay elements are used very less. Yes, thank you very much.